No, no. I started doing it. Where are my students?
I don't know.
We're gonna start now.
How are you?
Fine, 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 fine. Never, don't bother about it. do something. I have a plan. What's the plan? No, first, before we continue with the matter itself, I would like to act as a kind of advocate for my cause. I understand you have a feeling why we need all this. Why all these strange signals and strange currents and so on. Why should we have any interest in this? You have this feeling. Why? Just because to I have assembled a very simple network. I have a source. This one be my first signal. I have planted a current sensor. This will be my second signal. And very simple incandescent lamp. I can switch it on, make it bigger for my viewers. So, yellow line is the voltage and blue line is current. Of this small bulb. Everything okay? All fine as electrotechnics theory teaches us. Okay. This was simple. This was easy. What about this one? Take a look. Nice deco. Blue line, current of the deco. Red one. Is it sign? Is it something electrotechnics theory teach you about? Something goes wrong here. Let's try this economy. This is current of this Gibbs economy lamp. It's something electrotechnics theory teach you about. Something wrong here. Yeah. Maybe this small LED. Current of the small LED one. Something more. Oh. maybe this. Beautiful. Where is sign from electrotechnics theory? Somewhere. I will bring something bigger. Oh. Oh. Ah. That's what happens with small personal computer. It's currented. It takes from the network.
The blue one is current.
Blue one is current. Yellow voltage. Funny, isn't it? Problem we have. Real. Yeah, this is problem. We need tools to deal with something like this. It's our day's reality. Electronic, smart world, consume non-sign current. It's our day's reality. Need to do something about it. Okay, let's go forward. I'd like to show one problem. Needed to be tackled. One problem, what we will need solve. 1 second, where is my tiny application? Yeah, here is my tiny application. Need to switch. Come on. Need to attach my touch my TV to get visible my application. Small application. Up. If you remember, in our previous lecture, we made a small conclusion. What signal like this one, with amplitude t by half minus t by half, such a rectangular signal can be substituted as 4a divided by b, sum from 1 to infinity, sine of double I minus 1 omega divided by minus 1. And we limited ourselves with 3. So we get what this? First harmonic, first plus third, first plus fifth. The red line is what we saw in reality. And I draw such spectral diagram. 100% of the first, 33, 1/3 of 3 omega, and 20%, 1/5 of the fifth harmonic. As you can see, closer and closer. I can, in digital world, I can add more. Now, this blue line is sum of the first 10 components. It's Sn, sum of n components, where n is 10. Clear? Here is my original. Let's say 25. Closer, isn't it? 50. Better. 100. Better. But something. Do you see what this peak do not disappear? This one do not disappear. I can have 200. And still here. You see the blue peak here. This one do not disappear. This one do not disappear. At a sharp change, rho, Fourier rho, goes up, oscillates around, and then everything fine. Problem. This will not disappear. This refuse to disappear. It's a problem. Remember what I told at the starting point. What Fourier rho has its how to say precision is valued averagely. This means what it will ignore small. What I mean small differences with small energy. Energy in this peak leads to
0, because it will become infinitely sharp, infinitely thin, yeah? So area of this peak goes to 0, and energy of this peak goes to 0, but amplitude difference remains. It became, how to say, narrowing, and it narrows. It became extremely narrow, but difference remain. It's this point was obvious for Lagrange. That's why Lagrange opposed Fourier idea. It's not disaster, but we need to how to say, we need to keep this under control. What's the difference? For many years, no one was able to take, how to say, to dig to the root of this problem. It just happened. Until worked in the United States, physicist Gibbs performed detailed analysis. From this point, this problem, what Fourier role, at a point of sharp change goes, how to say, it overshoots. It goes above level, then down, and kind of oscillating, returns to where it should be from the starting point. Kind of decaying oscillation about around, better to say, around our signal line. So, name of this, Gibbs paradox. It's paradox. Why? Fourier role works a bit strange around points of sharp change. So to understand nature of this behavior, we need to take a look into Gibbs theory. Where is my Gibbs theory? So, what's the Gibbs idea? May I return to, may I go here? Yeah. Okay, X Gibbs formulated. Let's say we have some function of X with point of interruption, let's say AB, point of A. So, and epsilon goes to 0, A minus epsilon is A capital, and in the same time, A plus epsilon is B. It's an interrupt or switched function. That's what Gibbs started from. To reflect this, Gibbs introduced a special function, or proposed to use a special function. How do you think? What's the name of the function? Gibbs function. So, Gibbs function equals to minus bx 0. It should be produces 1 and minus 1, 0. Something familiar? Huh? It's our rectangular function with E1. Only note that I usually draw it as a function of time. Here, if you draw it in coordinates omega dot, this will happen. Do we know Fourier rho for such function? Of course we know. It's a rectangular function with amplitude 1, meaning what Gibb's function can be substituted 4 divided by p sine x plus sine 3x divided by 3 plus sine 5x divided by 5 plus blah blah blah. So it equals 4 divided by p. Sorry. Somewhere I change from 1 to infinity. Sine double I minus 1x divided by double I minus 1. Now what can be done? We can now record our interrupted function as b by half Gibb's function at the interaction point plus some uninterrupted one. We can separate this, let's say, computation or interruption point and function itself. That's me. What to understand what happens with Fourier rho, it's enough for us to perform a research on Gibb's function. If we would be able to understand what happens with Gibb's function, we will have ultima limit. We will have top case or worst case scenario for all Fourier decompositions. And because, see the question, what's the derivative when it goes down? Minus infinity. When it goes up, plus infinity. At the break point, ideal Gibbs function has the speed of change or rate of change infinity. So in reality, it may be different, but not these error for Gibbs function will be maximum possible. Yeah? Yeah. Should be known what at point x0, Gibbs function has two values, plus or minus 1. But Fourier rho has only one value, 0. Fourier rho converges averagely. Okay. it's, how to say, if you want to point a root of the problem, you can say what original function has two values at the point 0. Two values. Okay, here 1, 2, 1, Fourier law, only 1. Okay, let's do something to understand what Gibb's idea. We need to introduce Sn from x. It's 4 divided by p, somewhere from 1 to n, sine 2i minus 1 x divided by 2i minus 1. Sum of first n members of Fourier law. In my case now, n is third, n Sn, not x, is this blue line. Its sum at this moment n is third, and this line is this, not x. Physical generator produces only 5, so it's N5, and yellow line we saw before was Sn at N5. Now we have a third. Yeah? Yeah. What you preparing? Electrotechnics theory? And copy them. So, double I. Oh. How do we perform a research on functions? We may be interested in extrema points. Yeah. To find extrema points, we would like to perform analysis on blue line. What should we do? We should solve one nice equation. We should to find extrema points, we need to solve equation where first derivative of our function equals to 0. This will yield us extrema points. Tiny problem. X is what? 4 divided by p cosine x plus cosine 3x plus cosine 5x blah blah blah. Derivative of my blue line is a sum of cosines. Cosine x plus cosine 3x plus cosine 5x, so on, equals to 0. How to solve it? Any ideas? How to solve such kind of equation? Not an easy. Huh? You can, appears to me first time in your life see such kind of equation. It's not one well known how to solve. That's why Gibb's paradox, not for example Low's paradox, and Gibb's function. Gibbs, I don't know, very well new complex mass of or very well researched, perform a very good research on complex mass. But Gibb found one interesting role. Theory of complex mass says what if we can analyze F power J of this one rho F power J beta plus F power J double beta plus F power triple beta plus so on, what such kind of rule can be substituted as F power J alpha 1 minus F power J m beta divided by 1 power beta. Here plus with the m plus F power J m beta. Oh. Sum of m exponents can be substituted I saw such kind of rule used to approximate startup of the generator. Appears nothing close. But if we take a real part of this rule, real part of rho yields cosinus alpha plus cosinus alpha plus beta plus cosinus alpha plus double beta plus cosinus alpha plus m minus 1 beta. Real part of this rule looks very similar to our problem, to our sum of cosines. If we can what we can do? If we can separate real even time, I can do trick like this. F power alpha, F power m beta by half divided by F power beta by half multiplied by F power minus j m beta by half minus F power j m beta by half, applying Euler's formula, and here should be F power minus j beta by half minus F power j 1/2 of beta. This one equals to F power j alpha plus m minus 1 beta by half divided by, I don't need beta this way, multiplied by sines of m bet by half divided by sines of bet by half. And this one can be easily written to separate real and imaginary part. 1 second. Can I erase? Yeah? So it will be cosine alpha plus m minus 1 bet by half. Yeah, this is fine. Plus sine of alpha plus m minus 1 bet by half. Yeah, good. And all this multiplied by sine m bet by half divided by sine bet. Great. Here is our real part. So, real part of rho equals to cosine alpha plus m minus 1 bet by half multiplied by sine m bet by half divided by sum of bet by half. Cool. Now how to use it? Assume what double x is bet and alpha is x. Now, cosine x plus cosine 3x plus cosine of double minus 1 x can be written as cosine x sine nx divided by sine of x, or sine double nx divided by 2 sine of x. Cool! What means good knowledge of complex math? Equals to Yohoho. Super knowledge. BGV. I can write my sum as 2 divided by p from 0 to x sine double n t by sine t dt. T is actually variable. I can rewrite my blue line as an integration of its derivative. Since I knew what derivative is sine double n x divided by x, I just use auxiliary value t. Now, what about extremal points? For the range starting from 0 and ending by p by half, at the first maximum, extremal points corresponds to sine double nx equals to 0. This points allows me to pinpoint extremal points. In result, I will have copy divided by double n. What's here is my signal. I see such kind of oscillations. Yeah, this one corresponds to K1. It's the biggest. K is integer 1, 2, 3, blah, 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 till n. But the biggest one is the first. Now, magnitude. How far it's from? I can tell. Now I can tell. Its magnitude will be p 0 p divided by double n sine n t divided by t equals to 2 divided by 3. I should integrate from 0 to p sine y divided by double n sine y divided by double n. The y where y is a substitution for double n t. What do we know about sine of small angles? Sine of alpha, if alpha is very small, is approximately alpha itself. If I have large numbers here, if I have large n, I can substitute sine of y of n t when n goes to infinity can be substituted as y above n tail. What I'm writing? What interesting point? Actually, I'm speaking on this one. So when n goes to infinity, simultaneously should be 0. This point is double divided by p, from 0 to p, sine y divided by y dy. Meaning it's an integral sine of p. And value for its known 1, 7, 9, blah, blah, blah. What does this mean? This means what maximum possible difference between signal and its Fourier role is 18%. This one is worst possible scenario. All real will be better. Worst case scenario. Difference 18%. Okay, maybe I can start